So thanks very much for being here, and let's kick off with our first session, which is the focus on high productivity vehicles. So it is my pleasure to introduce you to your first speaker, Les Bruiser, the Chief Engineer from the National Heavy Vehicle Regulator. Les is the godfather of PBS vehicles, so we are really lucky that he's travelled down from Brisbane to be with us today. Thank you, Les. And here's the clicker that I didn't know was there.
How much time do I have?
You have 55 minutes.
Okay. Good morning, everyone, and thanks, Mal. It's an absolute pleasure to be here. I think this is my third breakfast, and it's an early start for me. You promised me a coffee, so anyway, I hope that you're not going to be sleepy, but anyway, so I'm doing two presentations. One is about high productivity and PBS vehicles, some of the history and some of the things what we are doing. And then also I've got another presentation which is talking about some of the tools what the NHVR has developed, which would help transport companies and road managers in terms of making decisions about the operation of those vehicles. So just quickly, and some of you would be familiar with this, that how innovative or high productivity vehicles have been developed in this country. My first job was in '92, the introduction of 25-meter B-doubles in Melbourne. And you can see that B-doubles, even with B-doubles, they went through development, and even if they look the same, there are significant differences between their characteristics. And what was happening in the late 90s, late 80s, early 90s, that we have developed all those different B-doubles, and the rules were different and the networks were different for those combinations. And then the high productivity combinations, we called them back then innovative combinations. It was mainly trying to assess their performance. So we used a number of tools there in terms of computer simulations, on-road testing, and we used a small number of performance measures to assess them and compare them to the conventional vehicles which were operating at that time. And that was the basis of their development. And here is a list, or just a few illustration. The AB triple, the B triple, and the larger quads, the BAB quads and the ABB quads. And these combinations were developed during that period of time. But they were based on individual assessments in the different jurisdictions. They had different rules. So it was difficult to have cross-border sort of operation with some of those. The networks weren't really available. So obviously some of the jurisdictions were more progressive than others. And I remember that, for instance, New South Wales back then wasn't really a progressive jurisdiction. So if you remember, some of you, that it was very difficult to operate any of those innovative combinations here in New South Wales. And just it's very funny that the regulatory developments are very slow. If you look at that photo from '95, that was one of my first projects up in Queensland with Queensland Transport, the testing of an AB triple. And we had officially in regulations, it was 2014, when those vehicles were introduced across the jurisdictions. And it's the same with some of the others. So unfortunately, the regulatory changes are very, very slow. So if we look at combinations, what did we have before PBS? We had general access vehicles, prime mover semis, truck and dogs. And in terms of, we had B-doubles, the different lengths and so on. And what PBS has changed, that it provided a framework and an opportunity to design or develop different combinations. So if you look at this is just the truck and dogs, what we currently have in PBS, and we don't have all of them up there. You can see that we have 3-axle truck, 4-axle truck, 5-axle trucks, and the same for dog trailers. So there is a different range, a large range of combinations what were developed under the PBS scheme. And it's the same for prime mover semis. You can see that there is a large variation in terms of what combinations would be available for transport operators to address their specific freight task. If we look at normally PBS level 2, that's a critical. We see that that's a very, very popular sort of class. So we are talking about combinations under 30 meters roughly. And if you look at what combinations we introduced for that class, we've got the A doubles, which are really star performance. We've got B triples in that. We've got a shorter A double, the 26 meter long up there on the right hand side. And we've got 30 meter long B doubles. And you see one of them outside there. Here are just a few examples for PBS combinations, and what this slide illustrates that now there is a PBS option available for each of the different segments of the transport industry. So you can see tankers, you can see this B quad there, it carries carrots, logging vehicles, container vehicles, so it's possible to design a PBS vehicle option for each segments of the industry. Now some of the stats, and I guess that's interesting. This is the stats for May 2025. So we have more than 27,000 PBS combinations on our book. And here are the yearly approved sort of numbers, and you can see that last year we approved more than 5,500 PBS combinations. And interestingly, I was just checking then when I was here in 2022, we had 14,000 PBS combinations. And now, and because I went back to my presentation and the stats showed that we had 14,300 or something. And now we've got 27,000. So within 4 years, we basically doubled a number of PBS combinations, which means that industry is turning towards these more productive and safer combinations. So that's basically, that shows the success of the scheme. These are the cumulated figures, what I was talking about before. And there is also a change. You can see these are the combination types in terms of which are the most popular. So it's still truck and docks, which we have the most of, more than 11,000 of them. But you can see that A doubles, the PBS A double, that's now the second most popular vehicle class. And this year and last year, we approved more A doubles than truck and docks. So, which is, again, an interesting sort of observation where PBS is heading. And obviously, prime mover semis, B doubles, and some of the road trains are there as well. So that's the PBS superstar, currently the A double. I had to use that photo up there with my favorite team, the Urban Storm colors up there, which was on display at the truck show a couple of years ago. But you can see that there is a big variation of the A doubles. And if you think about it, that this tanker here with the split axle groups, it's approved for, I think, 93 tons. Yes, we are struggling with access, and I'm going to talk about that a little bit later. But if you just think about it, that we moved from a B double class around 68 tons to a vehicle which can run with a GCM of 90-something tons. It's a huge improvement in terms of productivity, and these vehicles are also safe. So these are the fleet numbers again, and you can see that the dark green is the class of the A doubles, and you can see that in the last couple of years there was a huge explosion in terms of the numbers of those combination types. What's interesting that, and this is what I mentioned, that you can see the A-double numbers in terms of the yearly trends. Last year we approved more than 1,600 A-doubles addition to the previous fleet. So basically what PBS is, and you are much more familiar with this than a few years ago, but we are trying to design vehicles which can match the limitations of the networks, and also they comply with the very strict performance requirements what we put there. So we've got safety and infrastructure standards, and all of those vehicles are assessed against those. So, and you can see here that, for instance, that A-double, the 30-meter long PBS A-double, performs better than a shorter prescriptive B-double. So it uses less road space when it's turning around. Here is another demonstration in terms of the acceleration capability of the vehicle. There is a conventional truck and dog, three-axle truck, three-axle dog. Can we please run this again? And versus a PBS 50-ton. And you can see that the PBS combination is specified in a way that it actually accelerates quicker and can clear the intersection within a shorter period of time. It's the same. This is, I know that this is a big problem here in New South Wales and also some of the other jurisdictions in terms of railway crossings, and the question how come the networks which are approved for 26-meter long B-doubles, why they are not approved for 30-meter long combinations. And we can run this again, sorry. Then, for instance, this is just looking at how much time those two vehicles would need to clear the intersection, and that's important in terms of signal timing and so on. But again, PBS combinations must comply with very strict performance requirements. And we are working with those road managers and all the third parties to convince them that, yes, these vehicles would have good performance. Here is a logging example that obviously PBS vehicles will have to comply some other standards which are not normally used for prescriptive vehicles. This is an example in terms of that we sometimes limit the load height in order to achieve stability. Can we run this again? Sorry. You can see that that one on the, it's the same speed, same road network, same vehicle, same load, but it's loaded differently. It's got a higher COG position on the left-hand side and it rose. So some of the PBS vehicles are approved with specific payload height limitations in order to meet their performance. This is an other example, obviously livestock. This is this area, you've got lots of livestock vehicles. We are developing PBS options for that, and I think Scott will be talking about some of the PBS options. And you can see the same sort of thing, that obviously with the 4.6 meter high vehicles with heavy loads, sometimes it's difficult. Another example, a very popular one, the quad B-double, again 30 meter long. This is used frequently. So what are the trends? So we can see within the 30 meter and limit, we see developments in a number of combinations, and also we hear the demand from the industry to look at the length, because strictly speaking, PBS doesn't specify the length of these vehicles. We don't have length limit in PBS. That's all related to the infrastructure limitations in terms of route classification. But a 32 meter long or a 34 meter long level 2 vehicle has to meet the same sweat path than a 30 meter long or a 26 meter long. So there are no dimensional limitations in PBS. Some of these vehicles with the split axle or more two axle groups, and this one is which is on display. It's a little bit different, but I can talk about that later. But what you can see that we are doing lots of work because road managers are really concerned because these are all new designs, and especially local governments might not have the information, and it's not just local governments, road authorities, they don't have the information to understand how these new systems are working. So we have now significant modeling capabilities. You can see all these simulation videos where we can, for instance, looking at what are the side forces on the tires, how they would impact on pavement to help road managers to make an informed decision. Some of the other examples, that long semi with two tandem groups at the back, 24 meters long, and it's operating here in New South Wales as well as in Victoria and Queensland. Some of the container vehicles and some of the other combinations. So obviously this is a trend because we haven't had any increase in terms of axle loads in the last probably 20-something years. So we are trying to increase the productivity by putting more trailers or more axles underneath the vehicle. That's the only way how you can basically increase the GCM. And with having split axles, that's an opportunity. Obviously, with these vehicles, we have issues in terms of the infrastructure impacts. Now, while I think even when I was here a few years ago, PBS was still a little bit niche market, but it's not anymore. This chart shows that currently roughly 20-25% of the road freight task in this country carried on PBS or high productivity vehicles. So it's not a niche market anymore. PBS is significant for this country and the economy of this country. So I'm going to talk about the tools later on, but this is just an example that you compare a 9x B double, and this is what our tool actually does. And I just wanted to put up this slide. So if you compare a 9x B double versus the A double, a 30-meter long A double at higher mass limits, you have a payload increase from 42 tons to 55. And if you look at then what it means if you then translate that for a specific freight task, and I guess that's another important element of this, that the demand for road freight is not going away. So it's not going to go away. And unfortunately, we had a discussion last night about trains and the rail system. But it's not currently, the rail system cannot really deliver and cannot for certain freight tasks. So the proportion of the freight task where there is a contest between road and rail, it's only around 15%. So 85% of the freight task where there is no viable rail option. So therefore, this is why we are pushing for more productive and safer vehicles, because they are all delivering all those benefits. So back to this slide, so you can see that if I look at for a specific freight task, because of the payload increases, we reduce the number of kilometers traveled, and because of the safety performance of these vehicles, you can see 76% reduction in the probability of a fatal crash. Just think about that. So definitely there is a safety message here. And if you look at that in terms of fuel consumption, 11% obviously CO2 emission, and that's a critical element these days because everybody is talking about the transport industry and how the transport industry could reduce greenhouse emission. And then the last one is in terms of, let's say, pavement impact. So if you look at the pavement impact for a freight task, it's around 30% reduction. So when you introduce these vehicles, individually the vehicles might be similar or could be a little bit more damaging than the vehicle what they replace. But if you look at the damage for the freight task, they are reducing the impacts on the infrastructure. We've done a study, and when we compared the PBS combinations to prescriptive ones, and generally this is the data that in terms of rigids, we've got around a 47% reduction in terms of crashes, and for Arctics it's 69. And we repeated this study last year. We haven't published the results. And the data is exactly the same. So despite of the fact that within a few years we doubled the number of PBS combinations on the road, they are still producing excellent safety characteristics. So if I look at PBS benefits over the years, these are just, again, using our tool. We probably saved more than 200 deaths. And just think about that in terms of that significant savings in terms of safety benefits, 180 fatal crashes. But what's important that we replaced roughly 8,000 vehicles which are not on the road anymore. And the whole country is struggling, and it's not just Australia, all the other countries are struggling with driver shortages and so on. So if we wouldn't have PBS right now, it would be a much more demand in terms of drivers and driver positions. And then are all the environmental benefits there, which are all significant. So PBS is a tool set, and there are some of my other inventions, and I know that these vehicles won't be traveling everywhere. So this is the Project London, how we call it, a vehicle carrying double-stacked containers that's operating in the port of Brisbane. And there is a triple there on the top. But what I want to just emphasize, that these vehicles are assessed against those standards. So there, on the right-hand side, you can see a photo of the stability test, what we performed to make it sure that this vehicle is, can we run this again, please? This vehicle is 7.4 meter high. So just think about it, that it's a very high combination, and stability is obviously, it's critical. And we had to do a stability test to make it sure that it complies with our requirements. And we also did simulations for wind loading. And we introduced operational requirements that when the wind speed is more than 60 km in the port, then this vehicle cannot be operated because it would be dangerous. Not dangerous, but risky. Here are some of the other things what we use. So PBS is a tool set. There are the super quads on the bottom. We conducted lane change tests, so looking at the dynamic stability. On the top, you can see Brisbane Metro, which is a new electric bus, 24.5 meters long, which started its operation. That was assessed under PBS as a tool set. And we are currently doing some work for the NTC because you may have heard that ministers decided that we're going to increase the height of the vehicles from 4.3 to 4.6, and we are trying to assess what it means. So what are the challenges right now? Access, and most of you who are operating PBS combinations or dealing with them, you would know that access is still an issue, especially in certain jurisdictions. And there is still a lack of uniformity between the jurisdictions, how they assess the impacts of these combinations. Unfortunately, the current law has significant limitations in terms of what we can do in terms of the NHVR, and the law review has been running for 7 years now, unfortunately, that's an extremely slow process but we are trying to change some of those limitations and make our operation more effective. Then all these technical policy challenges, like the introduction of Euro 6, it is just an example that decision makers in their wisdom, they introduced Euro 6, so that means you can have higher axle loads for Euro 6 vehicles, but it doesn't cover road trains. So what do I do with my 6,000 PBS A-doubles, which are, strictly speaking, road trains? So if there is an operator purchases a new Euro 6 prime mover, they cannot operate it with the same axle loads than if you just put it into a normal B-double. So this is just an example that we have continuous challenges in terms of how we address the technical requirements. We've got electric trailers and dollies, zero-emission vehicles, all those technological developments which are coming. And currently, we've got, even within PBS, we've got a relatively rigid regulatory framework around them. And then compliance and enforcement, and I know that our officers sometimes very confused, and the industry is very confused about the limitations and the conditions of certain PBS combinations. We have one PBS vehicle approval which is 2,200 pages long. It covers roughly 8,000 different combinations. If you print that thing, it's a bloody book. So how can we have an efficient compliance for that vehicle? How do you identify that vehicle which is on the road and out of 8,000 options? So it's a very difficult task, not just for the industry, but also for then HVR, for our people. So it would be good if we could come up with some easier and better way to manage compliance. We mentioned just during the breakfast, here is a good example that in terms of the networks, that in some jurisdictions there are no networks available for some of the PBS vehicles. This shows the PBS level 2B permits on the left-hand side, and also the networks which are available. You can see that in Victoria and also in New South Wales, there are networks available, so there is more certainty for transport operators if they want to run these vehicles. And unfortunately, in Queensland, they haven't joined the national notice at this point in time. And what it means that, look at the permit numbers on the left-hand side. So you can see the dark blue, that's Queensland, because there is a huge request for permits, and that means assessments, it means time, it means money, resources. So we are trying to work with all jurisdictions to make it sure that the networks are specified and available. We did this testing last year. How do we adapt technologies? And this is when PBS was drafted back 20 years ago. We didn't have some of the technologies. Can we please run this again? So PBS currently doesn't deal with road stability technology, and this is what we did. We tested an A-double, and look at the top, which doesn't have, when it was switched off, and the bottom one, when the system was operational. This is a special test. It's called Les's wiggle because it's really pushing the vehicle to the absolute limit. And when we first published this, people were asking that how can the vehicle operate with those trailing wheels on the side around the city? And obviously that was just there for safety. But you can see what the impact is on what technology can deliver. And the issue is, how do we put that into PBS? So let's say if you have a livestock vehicle where the stability is not as good, but you have technology fitted, then can we approve that in PBS or not? So where do we go from here? Obviously, one thing is that we are trying to do to migrate vehicles out of PBS. If you look at the truck and docks, we've got 11,000 or 6,000 A doubles. Can we come up with certain templates what we can provide to the industry and say, okay, build your vehicle within this specification envelope, and you don't have to go through the PBS process, and the network is already available. That's where, for certain sectors of the industry, would like to do that. So we are considering that. Obviously, working with road managers, and you saw some of those examples, providing them technical information assistance when they are making their decisions. Internally, you can see this huge jump in terms of the PBS numbers. How am I going in with time? Okay. We saw this huge jump in terms of the number of PBS combinations. We have to manage that. So managing 27,000 PBS combinations, that's a huge task, and individually that's probably more than 65, 70,000 individual units. And those vehicles, we've got vehicle approvals and design approvals and certifications, so the process is very complex. We are putting significant resources into the management of the PBS scheme. So that's an issue. Updating performance standards, it's mainly what I mentioned in terms of how do we address some of those technological challenges and the new vehicles which are coming into the fleet. And the last one, and this forum is probably one of those, we are trying to promote the benefits of the PBS scheme and enhance the understanding and acceptance of these vehicles, because generally the data show that these vehicles are significantly safer, they are more productive, they provide environmental benefits, and they are not that damaging to the infrastructure. So probably that's the last slide what I had in this section. Are we going to have questions now or later on? Or okay. So if we could have the other one, other presentation, please. We have an area which is working or developing. It's dealing with mainly logistics and very effective in terms of looking at different data sets and trying to develop tools for all stakeholders to help with the introduction of these or operation of these vehicles. In terms of, I mentioned this, that the freight task is significantly growing, and some of the latest predictions are there that between 2020 and 2050, there will be a roughly 70-something% increase in terms of the freight task. We've got population growth, we've got the economy is growing, and so on. So there is a huge demand for road freight. Now, even if it's not 77%, but just 50%, it's still a huge number. And if you're just trying to translate that to, let's say, number of trucks, number of vehicles, that means if you want to carry that increased freight task, you're going to have a significantly larger number of fleet. So that means more heavy vehicles on the road, more congestions, more potentially more crashes, more environmental benefits. So in terms of what PBS delivers, it's addressing some of those. So there is a huge demand in terms of productivity that, how can we deliver this freight task more efficiently? And some of our internal sort of calculations that obviously the red tape has a huge impact on each of the stakeholders, unfortunately. So here are the stats in terms of the heavy vehicle crashes. And obviously we were trying to put a dollar figure around the cost of those crashes, because that's a cost what this country has to spend on as an impact of these crashes. Obviously, 2023 wasn't really a good year, but even though that all of you who are running vehicles, you know that in most cases these crashes are not fault of the heavy vehicle driver. So the transport industry in general, even that heavy vehicles are involved in some of those crashes, but it's not the fault of the heavy vehicle, but mostly of the light vehicle. I think I don't want to get into political debate about the environmental policies of different governments and so on, but there is a huge debate around that and a huge push on the transport industry, and not just on the transport industry, but also other sectors of the economy to reduce greenhouse gases and emission. And in terms of the heavy vehicles, unfortunately, they are contributing significantly into the emissions. So while they are only representing a relatively small percentage of the fleet, their contribution of the carbon emission is roughly, one quarter, which is large. So what we did, we developed a number of tools which can sort of address different areas of the operation of these vehicles. We've got the freight pass, we've got the pavement impact calculator, we've got a historic access reporting tool, which is looking at permits, and also another tool which is trying to put a monetary value around those activities. And we need sound with this one, please. Sorry. And this is a video which was just created shortly when the NHVR Go was changed, a month ago or 6 weeks ago. We moved from the Ford portal to NHVR Go. So this is a short video talking about these tools.
As a road manager, the decisions you make every day have a far-reaching impact on your community, its safety, its environment, and its long-term economic growth. Whether you're handling access permit consents or managing roads and assets, it can be a complicated balancing act where decisions often hinge on your judgment and experience. And as road freight demand continues to increase, making the right long-term decisions on heavy vehicle access has never been more important. Which is why we have a range of tools for road managers on NHVR Go, including technology for self-service network updates, plus high-quality data and analytical tools, all designed to support your decisions on heavy vehicle access and provide you with the information you need in one place. Let's take a closer look at two of these tools, the Heart and the Rapid CBA. First, the Heart lets you generate historical permit data for your network and beyond. It also helps you spot trends in heavy vehicle usage across your network to give you full visibility of past access decisions, and the tool benchmarks your decisions against other road managers Australia-wide. Then, building on the Heart data, the Access Permit Rapid CBA tool lets you evaluate the time and costs of administering those permits, both now and in the future. Used together, these tools can help you find new efficiencies, like identifying permit applications for the same vehicle type that are being submitted and approved over and over again. The tools available on NHVR Go can help you evaluate the impact of administering permits and learn more about how your networks are being used to reduce your permit administration costs. If you decide you want to add roads to your networks, you can use the Network Management tool, which allows you to update heavy vehicle access as well as assign conditions and restrictions to the roads. You have the ability to reduce the burden of permits and open up road access. meaning ultimately the ability to control your network is in your hands. On NHVR Go, road managers also have access to use the Freight Pass. This tool makes it easier to compare the impacts of specific heavy vehicles by factoring in distance, payload, and trips needed to build an apples-to-apples comparison of how vehicles really stack up over an entire freight task. The Freight Pass helps you to weigh up these factors against your priorities and understand which vehicles and configurations strike the ideal balance for the road networks you manage. Then, using the Pavement Impact Comparison Calculator, you can estimate the long-term wear and tear caused by different vehicle types on your network. Begin comparing specific combinations on different pavement types to uncover opportunities where favouring a more productive vehicle might have a lesser impact on your roads over time. Used together, the tools on NHVR Go can help you evaluate the impact of administering permits to better guide your access decisions and give you the opportunity to save time and free up resources. Your network is in your hands, and you can make access changes at your fingertips. Learn more about NHVR Go's growing number of tools and information to support you in your daily decisions by visiting nhvr.gov.au/go.
It was very well done, but I think it shows that the NHVR is working extremely hard to make decisions easier for all the stakeholders who are involved. I'm not going to do each of those tools. Probably the main thing is, because I have to finish, that these tools are available on our website, but we are also working on an app. So hopefully in the near future there will be an application which you can download on your phone and so on, which gonna do the same sort of functions what these tools are doing. I mentioned this in terms of this is another example what you can do. The video mentioned the cost of permits, and also that's a key element. Last month, we had 18,000 permit applications. So the permit applications is a big, or the number of permits, that's a big burden, not just for the road managers, because they always obviously have to allocate resources in terms of assessing those permit applications, but also for us, this is a huge task in terms of managing those permit applications. So in my presentation, when I talked about the networks and having gazettes or national notices which specify networks for the different heavy classes is important, because that reduces the number of permits. I think this is all specific for the tools, so probably I'm not going to get into the details of that. Because what's the main thing is that where do you find these tools? It's on our website, and then you can play with them or use them for your access management decisions. So thank you very much. That was the two presentations. Thanks again.
Thank you, Les.
Do you have questions or later?
And yeah, you were worried about going over time, and you've actually finished 10 minutes early. Early. So that because Scott's not online yet. So I'm really happy if you want to do some questions while we've got Les here. We've got a running microphone, don't we, Sam, somewhere? Yep. Does anyone have a question for Les? Excellent. Andrea, can we get Sam, can we run them? Can you put your hand up again? There you go. I'm going to move so you can answer it.
Thank you for that presentation, Les. My question is that if the heavy vehicle fleet currently is 4% of all vehicles, with that projection that the freight task is going to increase 77% to 2050, what kind of percentage would that be of all vehicles?
In terms of percentage, it's not going to be. It's going to increase a little bit, but at the same time, how the heavy vehicle fleet is growing, you've got all the passenger fleet which is growing at the same time. So the relative percentage will not be significantly higher. My prediction is that it's going to go up probably to 7-8%, but not above that value. And you have to also consider that there are also other movements which are influencing that. So, for instance, you will see that these days more and more people ordering goods online. So that means the delivery of the smaller sort of packages and so on, that requires a different fleet, and some of those vehicles are not classified under the heavy vehicle law as heavy vehicles, because we are dealing with vehicles about 4.5 tons. So there will be a huge growth in the van. In the van type of vehicles which can deliver packages in an area very efficiently. So I think there will be a jump in those numbers, but overall the heavy vehicle fleet percentage, I think, will not be changing significantly. The numbers will, but all the other vehicle numbers are growing at the same time.
Thank you.
Come on. Ask questions.
G'day, Les. The truck and dog notice that was released a few years ago to try and reduce the number of truck and dog combinations in PBS. Do you have any data on how many less combinations are choosing the PBS route as a result?
Because we are within France, a very, very small number. Unfortunately, the idea was good to create that notice, but legally it's extremely difficult because of the legal classification of the different vehicle classes. So those truck and dogs are still regarded as PBS combinations, and they still had to go through specific access applications. So those operators who have been running, let's say, truck and dogs, and they had their PBS permit available, if they wanted to switch to that notice, then they had to go through with a new application because that's a different class of vehicle, and we needed to get consent from the road managers for the same bloody vehicle, which is just ridiculous, but that's how the law is currently written. So this is why with what I mentioned in terms of migrating out, we are trying to find a legal way how we can move away from the current classification of PBS vehicles and put them into a generic sort of category like Class 1 or Class 3. But unfortunately, that notice wasn't as successful, even though that I think the specification what we created was very, very useful. And in our calculation, roughly 30% of the existing truck and dogs would comply with the specifications. So I think it was a good attempt, but unfortunately, because of the access restrictions or access issues, it didn't work as much as we expected.
Just to follow up, is there something you can learn say putting in A doubles into a similar sort of program? Is this
So
something we can do?
we have already created A-double templates based on the reference vehicles which are in the current notices. So we designed a range of A-doubles. We started with the tipping ones, where we have prescriptive dimensional limits around the vehicles and some other requirements in terms of engine power and suspension and so on, which would mean that if you design a vehicle, that vehicle would comply with PBS. So that would mean you don't have to go to a PBS assessor and a certifier. So that's the way how we are trying to do it. But again, that means it's going to be probably a class 3 notice. And we still have some of the issues that, for instance, under PBS, we provide exemptions for certain dimensions. So let's say for truck and dogs, if you have a longer drawbar, we can provide an exemption under the PBS. Now, if you move a vehicle out of PBS, then what is the legislative power what we can utilize to provide that exemption? So there are some of these nuances what we have to resolve. But yes, we are working on an A-double template, which would be, I think, very beneficial for the industry, especially for certain sectors. I mean, if you look at let's say the grain or vehicles, those tippers, they are very, very similar. Yeah, you might have differences in terms of prime movers and dollies and so on, but roughly they are very, very similar, because within that dimensional limit, you don't have too many options to play with.
Thanks, Elise.
Jackson? There's a question over here. Oh, sorry. And now I'm running a microphone too. I'm multitasking today.
Les, I guess following on from that previous question, if we've had 6,000 A-double applications or something in the last 12 months or whatever the number was you predicted up there earlier, why have we still only got 3 reference vehicles for A-doubles? Particularly one without a 3-axle dolly underneath it.
Yeah, that's a good question.
Video.
So we've been putting significant resources into trying to have work with jurisdictions to establish a nationally accepted assessment method, and those reference vehicles are critical for bridges. So the interesting thing is that when the jurisdictions created reference vehicles a couple of years ago, I wasn't able to design, as a chief engineer of the NHV, I couldn't design previous vehicles which complied with all the reference vehicles across the nation. So I couldn't design one. So that shows that until we've got agreed reference vehicles across the jurisdictions, and that's happening now, then it's very, very difficult. On the top of that, there are those things like tri-axle dollies. Some jurisdictions are all right with them. Some jurisdictions are not supporting them because they are concerned about bridge impacts, and also so you cannot run them with the maximum loads, which is, I think, not quite right. But we are working on them, and there is a national project which is happening based on the Tasmanian assessment system, which means that there will be an automated assessment method for structures in the future. I'm not sure if it's a near future or it's far away. But that means that you would be able to put in your vehicle, your individual vehicle, into an application, and that's going to map all the network which will be available for that vehicle. So that's going to change the need for reference vehicles. But you are absolutely right. Unfortunately, that's still the case that individual jurisdictions are assessing structures with different methods.
You can have last name, Paul.
Thank you. Les, just lastly, do you see the 30-metre A double as being the most beneficial combination in PBS, or do you think that perhaps the South Australian combinations of 42 metres may become a more prevalent combination?
I think the 30-metre one, I'm extremely pleased with the numbers because I was really struggling back in 2011 when we put the first one on, and I didn't really think that a few 10 years later we're going to have those vehicles running everywhere. Those are basically workhorses because they are replacing the B doubles. So suddenly you've got a vehicle which is much more productive. But I understand that vehicle is not suitable for everyone. That 30-metre length limit is very restrictive for certain sectors in the industry, and also it reduces the flexibility how you can utilize that vehicle. And in terms of the engineering assessment, there is no big difference between a 30-metre long or a 32-metre long combinations or a 33-metre long combination. And especially that they have to meet the same safety standards and the same infrastructure standards. Some jurisdictions have recognized that, and we've got longer vehicles running in New South Wales, in Victoria, also in Tassie as well. And if you think about another fact, that the longer vehicle would give you an opportunity to extend the axles. So in terms of the impacts on bridges, if you have a 32.5-metre long vehicle, that's going to have less impact on the bridges than a shorter one, because then with a shorter vehicle you put your axles more together. So I think that currently, there will be a change. Having said that, you will see, I think, in Scott's presentation that PBS provides an opportunity to develop longer combinations which would still meet the performance requirements for shorter vehicles. So that's possible under PBS. The question is, how can we address the increased length, the effects, what it means in terms of traffic, what it means in terms of railway crossings, stacking distances, parking areas. We have problems in certain, some of you would know that when you pull in with a longer vehicle, it's very difficult to find a spot at the servos where you can put those vehicles. So unfortunately, road design hasn't followed the advancements what we have achieved in terms of vehicle design, and we are trying to work with road designers to address that. So I think there will be a new star vehicle in the future. That's my guess.
Thank you.
Thank you very much.
Thanks, Les. Okay, so Les is still hanging around for the rest of the day, and I've got a little time scheduled after this next speaker for Les and for Scott to both answer your questions. So if you've still got PBS-related questions, keep them coming. All right, so it's my pleasure now to introduce you to our next speaker. Oh, thanks, Sam. Are you able to flick over to the Teams feed? So joining us online today is Scott Greeno, the Executive Director of the Transport for New South Wales Freight Branch. So Scott's going to give us that New South Wales perspective that Les was talking about in relation to high productivity vehicles. So good morning, Scott. Thanks for coming.
Morning. How is everybody?
We are great. Cold, but great.
Excellent.
Awesome.
Excellent.
So, yeah. Cool. Over to you.
Thank you. And apologies all that I couldn't make it in person. It is always a great session to be able to get out to, even though it must be very chilly there this morning because it's cold in Sydney. In many ways, we could have just ticked my session off with Les at the end there. It's good to always hear when we're on the same page as the regulator and certainly share some of the frustrations that Les talks about with being able to get access faster for these innovative vehicles. So we've got a few things I'm going to go through today, but as you can see on there, my name's Scott Greeno. I'm the Executive Director of the Freight team. So for anybody that I haven't met in the room, hopefully we will get a chance to catch up very soon. But one thing I'll firstly, as always, Transport acknowledges the traditional custodians of the lands where I'm dialing in from and where you're meeting today. So I'm in the land of the Gadigal people, and pay my respects to elders past and present, and extend that respect to any Aboriginal Torres Strait Islander people in the meeting room today. There's a few avenues that we're taking in New South Wales. One thing that's not on the slide here, and because it came up very, very recently, you may have seen some messaging come out that the government has released their response to the freight policy reform program. So over the last 18 months, there was a significant drive in New South Wales towards a step change in freight movement across New South Wales. So there was a range of things that were factored into that review. That included ports, rail, road, sustainability, industrial land, workforce, everything to do with the way goods move across New South Wales into, out of, including export markets right up until they get onto a ship. That report was given to government. It was led by an independent panel with 3 members. So they were Dr. Kerry Schott, Lucio Di Bartolomeo, and Dr. Hermione Parsons. They pulled together a report to government after extensive interactions with people such as yourselves in the room, and hopefully a few people in the room are able to contribute to that reform consultation process. So that was given to government with 95 actions, and the government have come back with a response to say that they are adopting all of those 95 actions. They had some clarification on some elements around port botany and its efficiency program that happens there. So they've talked about a couple of those actions being consulted on during the implementation phase. And they also highlighted that they want some additional work done be led by Dr. Kerry Schott on the movement of goods at night time, in particular in the Sydney area. So what the opportunities are to enable that movement better. So that's a significant step change for us. That program now launches into implementation. It will take us a little bit of time to get all the ducks in a row to have an implementation plan for that, but you'll start to see some progress on that in the very near future. Good news is there has already been progress on some of the findings that were endorsed earlier in the process, and that includes the Towards Net Zero freight emissions policy in New South Wales and the New South Wales heavy vehicle access policy. And that heavy vehicle access policy, you'll see some elements, particularly in the presentation today. So the slide you have in front of you is a condensed version of what it is that we're progressing towards. So we've seen these as most critical elements, particularly when we think about the road space. So that agile and resilient networks, unfortunately, we see that more and more natural disasters impacting our networks. And when you think about the secondary roads that become heavily burdened by detours when major corridors are cut, sometimes those, or in most cases, those secondary corridors are not built or designed for the volume of traffic that then starts to use them, and particularly heavy vehicle traffic. You see that there's impacts around pavement where you also see that the rest stopping opportunities are insufficient to handle the type of volume that you have there. And combining that with drivers that are unfamiliar with the route and not usually travelling that way, obviously in a heightened sense of confusion kind of environment, then all of those can come together to make for a very less than desirable outcome for drivers trying to move freight and schedulers trying to move freight around the network. We're also going to talk about some innovative vehicles and build on what Les was talking about before, and that question at the end, I'm not sure who it was from, sorry, but that was a great question about what does the future look like for vehicles. I know at the moment A-doubles are certainly the flavour of the month. If we wound back a couple of decades, the introduction of B-doubles was a massive shift forward. What we're looking at is making sure that we go as far as we possibly can, because any high productivity vehicle with that extra length and the complexity of PBS with the axle configurations, they all face the same challenges. So let's not do this piecemeal, bit by bit, trying to extend vehicles a metre here, a metre there. Let's really tap into what PBS has available to it and try and dig up all the gold once we've gone to the trouble of getting down there to pick up any out of the hole. Of course, streamlined access. Les mentioned that with the automated access systems that are being worked on. We'll go through that in a moment. The benefit of telematics and data, and hopefully you'll see the benefits of those start to flow back in, and I'll give you a hint as what sort of things to look for on how benefits materialise for industry from sharing telematics and data. And that strong partnership is not just between government and industry, and recognising the challenges and benefits from both to both sides, but that also extends to other parts, other stakeholders of this. So we work very effectively with the NHVR and really appreciate all aspects of the NHVR that you'll see Les in the room, and I'm sure Beth will be there as well. That relationship is strong in New South Wales, and we're very grateful for that. But also local councils, rail infrastructure managers, etc. There are federal government. There are a lot of people that are involved in this process to get better outcomes for industry and New South Wales and the community in New South Wales. So they are going to be critical for us. So this slide, just trying to condense everything down to one slide for those items. I'll let you digest what's on here. The reason that we've put this up is that it is indicative of the vehicles, the innovative vehicles that we have in the heavy vehicle access policy. Now, one thing I have to stress is that there is no requirement for industry to get these vehicles. There's nothing stopping industry from having innovative vehicles of their own that meet designs that meet the requirements of the network. There's no push to get away from A doubles when they suit particular industries better than others. So the talk about 30-metre vehicles and their popularity, they're very effective for moving shipping containers, 40-foot shipping containers. They're great at that task, but what we've found is a significant spike in 33-metre A doubles in and around Sydney, coming into and out of Sydney, being able to move palletised freight in a more efficient and effective manner. But these vehicles, the challenge that came up some years ago was it centred around livestock. So there'll be people in the room that may have participated in this process. But effectively, the overriding thought pattern not that long ago was that livestock couldn't possibly achieve PBS. So there was no way to be able to have PBS vehicles that were livestock vehicles. There was also, for very good reasons, a strong desire to retain the deck areas that are currently used in the standard B double combinations, the 26-metre B doubles, and of course the derivatives of those, which come out as the modular B triples and the modular AB triples. So that challenge was something that we thought we'd take on, and Transport for New South Wales then engaged a PBS assessor, and we had a significant challenge for them. We said to them that what we want is a 26-metre B double that performs at PBS level 1, and it is able to and is a livestock vehicle that's able to carry the same amount of payload as the current 26-metre B doubles at livestock loading masses. So that's HML equivalent. Fair to say that their initial response was it's impossible, it can't be done, but of course they worked very hard for us, and those vehicles aren't represented on this slide because they require a quad axle on the rear trailer of that 26-metre B double you see there. That would be a quad axle, and they require wide single tyres for stability reasons. But apart from that, they would look very similar to that vehicle, and they're able to carry the same amount of payload, 26 metres, and pass PBS level 1, every component of PBS level 1. Now, that's a significant step forward. The safety of that vehicle from a driver's point of view and the access potential. So no longer would we have road managers that are saying, well, this vehicle could be a risk moving through the network because of its increased swept path. That's not no longer a challenge when you have a PBS level 1 approved vehicle. But we're mindful that there is a significant cost involved in saying to industry, well, here's a far better vehicle. Go out and upgrade your current vehicles to these vehicles and your current trailers become worthless. So that certainly was not a path that we would entertain. So the vehicle that you see there, the 26 metre B double, it's listed as PBS level 2. This isn't one of the innovative vehicle combinations, but there are innovative vehicle combinations that are also that same design, 9-axle B double, can be used for grain, can be used for logs, can be used for general freight, etc., tippers, that all perform at PBS level 1, 26 metres, 9-axle, standard dual tyres, no significant difference apart from a steerable axle on both of the triaxle groups. And that's what gives us that significantly better performance. But what I really want you to soak up for this slide is in that space, so livestock aside, for all of the other freight types, every other freight type except for tankers. So tankers weren't included in this because of the nature of tankers, depending on the payload that you're moving, then their centre of gravity and the impacts on static rollover threshold, etc., can all be challenging. So we drew a line under tankers and said we'll allow industry to do those in more detail. But every other type of trailer combination is able to use these types of combinations. But the really unique part, and hopefully you can see my mouse when I move across to here, if you have the trailer set from a 26 metre B double, you are able to use, for the innovative 26 metre B double, you're able to pair your current lead trailer, so without any change to your current lead trailer, to that innovative 26 metre B double trailer set, and that becomes a 35 metre modular B triple at PBS level 2 performance. So that's matching the 26 metre B double networks as a base network. And I'll get to what I mean by as a base, because there'll be some exceptions. And probably the most exciting news that people would see on here is that that is the same for your 42 metre AB triple. So this is a 42 metre vehicle. All you need is your existing rear trailer attached to an innovative 26 metre B double trailer set, and of course adding a dolly, and you then have a 42 metre AB triple that performs at PBS level 2. So thinking about that 26 metre B double network as a base. Over on the right-hand side, you've hopefully had a chance to absorb just how significant the change is in the productivity, the sustainability of these vehicles. The impact on the road network for road managers is significantly less. There is a huge opportunity to be able to use these vehicles without sacrificing the value and the return on investment of your current trailer stock. Now, as I said, that doesn't prevent you from using other types of trailers, your A double combinations, your or other innovative solutions that you have. It's around making sure that you have the right performance for the vehicle, and that axle grouping for a combination is able to move through the network, particularly over the structures. And this is those caveats of where we still have constraints on that B double network, will be that you can't hide the mass and the axle spacings of these vehicles as they go across bridges. So each of the bridges need to be assessed, and that's a big piece of work. The other thing is that as vehicles get longer, then they also interact with rail level crossings differently. And as a result, we're working very closely with local councils and very closely with rail infrastructure managers to come to industry with approved networks. So the reason that we haven't released these vehicles more widely, we've been talking about them for a little while, is that we are making sure that we have usable networks to be able to provide to industry to be able to get them out on the road. But the concept of innovative vehicles that perform to the requirement of the road network, we are already providing permits for those on individual vehicle by vehicle, case by case basis. So significant opportunity here. We also have some other innovative vehicles that I don't have space on the slide here for. They're designed for intermodals in particular. And they are able to carry 20-foot containers at rail mass, so up to 34 tonnes for a 20-foot container without exceeding concessional mass limits. So for council's point of view, significantly better from a roadway point of view, but able to just load the container once, take it to an intermodal, put it straight on a train, and it goes into the port. Or, of course, coming back from the port as well for transporting goods back out to regional locations. We also have some combinations that are kind of a hybrid between an A double and a B double. So they use almost a gooseneck style concept. So there's a turntable on the lead trailer, and there is a dolly with a turntable on both ends effectively for the trailing trailer, the rear trailer. And with those types of trailer combinations, we've been able to get significantly longer vehicles with much greater productivity and still able to pass PBS at much lower levels. So a 30-metre A double at level 1, a 45-metre A triple at PBS level 2, and a 60-metre, let's say, A quad as at PBS level 3. So huge productivity gains and significant steps forward in performance and safety outcomes for both the road network community and, of course, for industry. All right, intermodal opportunities. As I mentioned, we do have these innovative vehicles. We need to make sure that we get, as the road freight network continues to be overwhelmed with the task that's required of it, we need to make sure we get the very best out of the rail network as well. So it sounds weird to talk about rail at a road event, but ultimately being able to move as seamlessly as possible, as efficiently and safely as possible between road and rail is a significant opportunity for regional New South Wales and also for metropolitan New South Wales. So we've got a huge focus on how these vehicles that I mentioned around 20-foot containers at rail masses without exceeding concessional mass limits on the road, how they're able to be used to and from intermodals to get that maximum velocity and flow through the rail network and drive a better outcome for that road-rail interface as we move goods across the network, particularly, as I said, to and from regional New South Wales. From a telematics point of view, often or in the past, and I think as a collective industry, and Les mentioned the industry is far more innovative, moves faster, is more often more mature and sophisticated than the regulatory bodies and governing bodies and jurisdictions that are trying to keep up. And what we've found is that the take-up of telematics was significant across industry before there was any sort of drive from jurisdictions or road managers or road authorities. What that telematics was being used for was very rightly so to manage the assets that you had as industry operators. What is very clear is that access to that same information, but for very different purposes and in a very different way, is significantly beneficial to road managers, asset managers, and as a result of that, far better for industry as well. So primarily de-identified information, telematics information, but the more detail that is able to be used, then the greater the outcome is for road manager decision making. So that decision making can be based around access. In the past, whenever a road manager, and particularly local road managers, that can be very challenged, they don't have the same resources that we do from a state road manager point of view to be able to make decisions or monitor the networks. And of course, a lot of the compliance activities are drawn to state roads because of the volume. So local road managers can often feel very alone in their decision making and how they handle the movement of heavy vehicles through their networks. But the access to telematics data means that instead of just saying yes and then not knowing what happens after that, they can say yes in a more measured sense. So once they say yes, they know how often their roads are being used. They know what routes are being taken so that they can then make smarter decisions, in, further access decisions in a more confident and assured way. So opening up more access because they understand how the visibility that they get through that. They can also make better decisions around maintenance. So what parts of their road networks do they need to focus on because heavy vehicle traffic is primarily what drives maintenance decisions on road networks. And lastly, how do we inform investment decisions? So for councils, that's funding bids. How do they then demonstrate that there is an evidence, data and evidence-based rationale to support the funding for their investment that they're asking for? What will be the benefit to industry of that investment? And even down to, from a state road point of view, we use that to better understand where might rest areas be more beneficial. Everybody's trying to invest as much money as they possibly can get their hands on to make the road networks and rail networks better for everybody that needs to interact with them. But there is never enough money to make everything exactly the way would like it. So being able to inform that with accurate evidence-driven insights means that the people that use those networks and more of the people that use those networks get better outcomes on a daily basis. So it's a matter of sharing data to make sure that the people that make decisions that readily impact your lives and your workplaces are able to make better decisions that are more fit for purpose and deliver more of those good outcomes that you're after. And on to agile and resilient freight networks. As I mentioned, we're really looking at how we can radically shift and expand the use of high productivity vehicles on the New South Wales network. Now, I know changes happen far too slowly in government, and it frustrates me as much as it frustrates you guys. And I know that I'm the face that comes and talks to you about what we're doing from an access point of view and why can't we move faster. But I would call out that that my team has worked hard to make sure that we are walking the walk instead of just talking about how good it could be. So you would know this is a location shot of BC Partridge Rest area, which is just south of Sydney on the Hume Highway, approaching Sydney from the south. This is an area that now has 36.5 metre PBS level 3 and 35 metre modular B triples, so not requiring a PBS approval. Modular B triples, we took the approach that modular B triples have the same performance as a PBS level 3 vehicle, and that's defined by the parameters that defines a modular B triple. So as a result, we have those PBS level 3 vehicles and PBS level 3 performing vehicles with a series of safety technologies and telematics monitoring, etc. But they are now accessing Sydney via the Hume Highway, and they don't just come near to Sydney and break down, like that are similar to be capable of that. They're not required to break down. They come all the way into Sydney, and they are going to those major distribution centres where the local Sydney road network can accommodate it and be able to get end to end. I think on this, in the past, there was contemplated around how do we get larger vehicles closer to Sydney and then break them down and take them where they need to go. But I think the greater focus is that how do we get better vehicles to go end to end on that trip so that they go right to their destination and they're able to be loaded, unloaded, etc. At the location that they need to be, and then they get back out onto the roadway, onto the state road network as quickly as they possibly can, and off to where they need to be next. So we're using a number of levers for this. We're obviously looking at the major corridors, the strategic corridors that are suitable for that. Hume Highway, Pack Highway are locations that are a little more blessed for, they don't have rail level crossings, for instance, so that's less of a challenge for us. They do still have some challenges for bridges, particularly the Pacific Highway heading north from Sydney. But wherever possible, we are looking at the right vehicles for the right task, i.e. a 33-metre vehicle isn't necessary for the one to then start moving pallets. So we're making sure that it's not about length, it's about performance, it's about getting the right vehicles on the road to be able to do that task as safely and sustainably and productively as possible. So the automated access that was mentioned before, so this is a huge project that is that started out of Tasmania, and whenever we talk about this, we should make sure we tip our hats to the work that happened in Tasmania. And this is about making those bridge access decisions faster. And the more that we get exposed to PBS vehicles and the different types of PBS vehicles, then the more we have a need to be able to make bridge decisions faster. In particular, bridge decisions faster, but in process faster as well. So that when we talk about reference vehicles, we do need to keep growing our reference vehicle library, because in the interim, that's the best solution we have to be able to provide networks. But ultimately, we won't need reference vehicles because every vehicle will have its own network in New South Wales, both on the state and local road networks. It needs to be friendly. If you design your vehicle to be less bridge friendly, but perhaps more task specific, and the route that you need is still approved, that will be the perfect approach for you. It doesn't necessarily mean it's a vehicle that will have as broader access, but it will be exactly what you need. And that's the type of approach that we're after, making sure, as I said, we've got the right vehicle, the very best vehicle we can for the work it needs to do and the roads it needs to drive on. So you can see significant opportunities out of automated access. I won't go through each of those elements in detail, but I think they speak for themselves, what faster decision and making would mean to industry. And those getting the very best out of our network, acknowledging that our bridges need to be to the point that they can break them and that they fail. And of course, nobody in this room or any room wants to be involved in a collision between a heavy vehicle and a train. And the challenge with high productivity vehicles or multi-trailer trucks is that they interact with trains differently. So naturally, heavy vehicles suffer significantly in a crash with a train, but a high productivity vehicle or a multi-trailered vehicle has the potential to also derail that train. So significant risk criteria or environment with that kind of interaction. So we need to be very careful about how we do that in a risk-based way. And of course, lastly, just that path forward. We have a very clear focus, and we are going through at the moment a restructure within Transport for New South Wales, and that is to make sure that we are aligned and fit for what the future holds. And ultimately, we need to make sure, so a big focus for us is making sure that the infrastructure that we provide, both road and rail, is fit for purpose. So it doesn't mean it's perfect, but it is able to do the things we need to do. And that includes a reasonable level of reliability and resilience in those networks, given the prevalence of natural disasters now. We're also focused on encouraging those innovative designs and getting those approved networks. So we're not expecting anybody to invest in these vehicles to them. So we're working on that as fast as we possibly can. And lastly, leveraging that data and strengthening our partnerships to make sure we make smarter decisions that benefit everybody. So we don't want to unload cost onto industry. Equally, we don't want to unload cost onto government and the community. We want to improve safety for everybody, both heavy vehicle drivers and other road users. We want to reduce the impact on environment because it saves costs. And if we do it in a smart way, it saves money. It also has obviously longer term benefits for the broader community. And we want to make sure that industry and the broad industry, not just the freight industry, but the New South Wales economy and communities have the lowest possible cost of living and the highest economic competitive capability in not just this country, but in the rest of the world. So that's our drivers for it. And that's what makes, that's what we make. I'm happy to stop sharing and come back to the room if anybody has any questions or comments.
Thank you, Scott. Anyone got, Paul, you've got the microphone. Do you have a question? Okay, we've got a question for you from the floor. Scott?
Good morning, Scott. Thank you for your presentation. A lot of your topic was focused on the coastal frontage that we have for transport, but obviously the people here today and most of us out here are concerned about our communities and efficient access to our farms, to our communities, and travelling through those communities to service the wider outback Australia. Now, currently we have permit requests in place, and I've actually got a notification this morning that a 90-day extension's been requested for one of those. And I'm wondering how you can help guide us and the NHVR in the process of addressing whatever the issues are that are preventing those permits from progressing, or giving us a response that as to what we need to do to progress those permits. The efficiency and safety of our communities out here is vital, and obviously we need to work with the rail networks, and I'm guessing that's the impediment. How do we work better with them to overcome the problem? And how do we get some feedback so we can develop a solution? As industry, we're not getting that feedback. We're just getting a door shut.
I'm not sure if you guys can hear me. I can keep going though.
Yeah, we can hear you. You go.
Yeah.
Yep.
All right. Well, assuming you can hear me, I referenced a couple of more Hume Highway centric and Pack Highway examples. The reason why I often use those, because we certainly, all right. Okay. You want to let me know when to go? Or? Okay. All right. So I did a more coastal, the eastern side of it. I often focus or talk to those is because typically, you guys can hear me now?
Yep.
Can you guys hear me now?
Yep.
Oh, excellent. Okay. Well, weirdly, I can hear you guys clearly, so that's a good thing. So I do often talk about those heavily congested areas, making changes, what that benefits, improvement to the road network, etc. Without those significant costs, they're more difficult. They're easier to those additional costs. So we often talk about very high-profile access areas. Such as the Hume Highway and Pack Highway, because that's where the volume of people see high productivity vehicles. And we need the same concept for regional. So to go from where people are used to seeing a 42-metre modular AB triple to then consider them looking at an A triple or even an A quad moving through their network. They're not used to seeing those in New South Wales, anywhere in New South Wales. So it's a challenge that we're trying to grapple with all the time. So far as the permits, I can't speak to the individual permits, and it's best not to tell me the numbers in this environment, but happy for you to reach out through the organisers to pass those details to me. But often, without knowing the specifics, like I said, they are a challenging discussion when it comes down to bridges and rail level crossings. And we obviously, as the state road manager, don't own every bridge, and we also certainly don't own the rail level crossings. The drive behind how we get better at that is that we are partnering very closely with the rail infrastructure managers. We're partnering with NHVR in that process so that the rail infrastructure managers get the same level of information, the same access to the portal to be able to make decisions. We're working with them so that they can be a part of that automated access system, so that no longer do the road managers make their decisions within 28 days or less, and the rail infrastructure managers need to take 3, 4, 6, 12 months to make their decision. That's the best approach that we have, is to really get inside the tent and say, this isn't a you problem, this is an us problem. We both need to work together to be able to fix this, and that's what we've been doing. And once again, thanks to the regulator, for the NHVR, for being active participants in that discussion.
Awesome. Thanks, Scott. We seem to have fixed our tech issue on this end. Thank you, Sam, for standing there with your arm in the air. Any other questions for Scott while he's online? Beth, do you mind running the microphone over to Ed? Because it's on your table. Thank you. Ed.
Thank you. Thanks for the presentation, Scott. Ed Wallace here from Midland. I'm really interested in the innovative 26-metre design. How did you get around the level 1 cap, GCM cap? Because it's as far as I'm aware, you've got a 50.5 tonne GCM limit at level 1.
Yeah, I think, and Les will be able to talk to the detail of this, but to be fair, PBS was brilliant, and it took us a long way, like far further than what I would have thought was possible. And I wasn't involved in this back when it stood up, so I take my hat off to everyone involved in it, because it was a massive step forward. But I think there was probably some compromises along that way, just because if you go too far, there's that old saying, if you go too far out in front, you suddenly look like the enemy. So there's only so much progress you can make at a time. And I reckon that there was probably some caps put into PBS at that time to make it easier for road managers to make decisions, and for everyone to get their head around how is this possible, and how, if it's all just up in the air, then we'll never know. We'll never understand what this is. And we've said, do you know what? The important part of PBS is about its performance. So if the vehicle can still do the same things performance-wise as a 19-metre semi-trailer, but be 75 tonne, then why would we say no? And there's nothing in PBS that really prevents it. It's more on the road managers to be able to then say, yes, we'll enable this. And like I said, Les can answer questions on the detail around that, but there's some stuff that people have kind of taken as a given, as a requirement in PBS, that doesn't necessarily need to be a requirement as such. So that's effectively how we've got around it. We've said it fits a performance, and that's the important thing. We still need to do individual assessments on bridges, which takes care of the mass. We don't have any extra axle mass, so it takes care of the pavement. The vehicle is better in every way as a result. So we've said, yes, that's what we want to support in New South Wales. And to be fair, the other jurisdictions haven't necessarily said no for all of those vehicles.
Les definitely wants to add something to that, Scott.
Just before Les speaks, just a little follow-up. You were talking about an intermodal on CML. So
yes,
and you referenced 34 tonne for the container.
Maximum 34 tonne, for the 20-footer.
So by my calculation, that leaves about 10.5 tonne for the prime mover and the trailer, which is very, very skinny for both of those. How does that actually work?
Yeah, the designs we absolutely will be sharing, and the reason why we haven't really heavily promoted them is that we've taken we bit the bullet, as I said, and in the past, what we would have done is gone, look at this amazing thing we came up with. Everyone goes and buys one, and then says, where can we drive it? And we're like, we'll get back to you. And that's rubbish. That's a really bad experience for people that are trying to do the right thing and buy a better vehicle. So what we've done instead is to talk about what that potential is and highlight them. And I'm happy to share those designs. That's no problem. They can be available, but we haven't really hammered them because there isn't the associated network with them. But what they do is they bring in additional axle groups to be able to do that. So they do have triaxle groups in this. It's almost like a dog trailer more than a standard trailer. It'll have for the lead trailer, because it has some additional mass that is required onto that drive group that would exceed the CML masses. I think you'll find in it from memory, and it's been a little while since I've looked at it, but I'm pretty sure it has almost a converter dolly style concept just for that lead trailer, whereas the remaining trailers in it, and we've got one that goes all the way out to 4 trailers. And each trailer can only carry at one 20-footer because obviously the mass. But there are significant opportunities with it, and it was all about the biggest issue that we face for local roads, and this is a very fair observation from local road managers, is that the axle mass tears their roads apart. So to get away from HML, we designed a vehicle that could do everything we needed it to do, but with only CML masses. And that meant you had to be pretty innovative with the design. But once you got that vehicle, of course, you can embed some pretty massive productivity and efficiency into your network if you're using an intermodal as your destination or start point.
Thanks, Scott.
Just a few comments. And Scott, you are absolutely right that at the beginning when PBS started, we came up with some values and performance levels, what we thought it was right, but we didn't really have the experience. But just I think this scheme has served us extremely well, so we weren't too far away. But back to your specific question, in terms of that mass limit, so that only applies for Tier 1 bridge assessment. So if you want to have a Tier 1 vehicle which complies with the axle mass spacing schedule, that's that mass limit. If you are at Tier 2 or Tier 3, the individual bridge assessment, what Scott was talking about, then basically you don't have that mass limit. And we have approved in the past a number of vehicles which are level 1 vehicles which were above that mass limits, because some of them, for instance, you might have an operation when you are not crossing any structures, so that sort of limitation on the mass is not necessary. If your vehicle can perform to the safety standards and the other infrastructure standards at that particular level, let's say level 1, then you should be able to utilize those masses. So yes, there are some standards where are mass limitations. Pavement horizontal loading is another one. We are changing that. Ministers approved that. Hopefully we can implement that in the near future. But strictly speaking, PBS doesn't have those limitations. So it provides you the flexibility to design vehicles, and the vehicles what Scott was talking about, those are good examples that yes, if you are thinking outside of the box, then you can have really innovative concepts around.
Hey Scott, Beth here. I'm not sure if you heard at the end of Les's presentation there was a question about A-double reference vehicles with tri-dollies in New South Wales. Did you catch that, or do you want us to repeat it?
Yeah, no, I did. We are, as Les mentioned, we are one of those jurisdictions that our engineering teams have concern around effectively the A-double and the distance between the triaxle group on the front trailer and the triaxle group on the dolly. So they have impact on our structures according to our assessment process, and that's where limitations come in for us for a lot of structures. What we're also trying to do is work towards what if we're able to allow, because there's significant benefits for triaxle dollies from a stability point of view, particularly when they're running at a little bit less than their maximum masses. But what we're looking at is there an ability for us to consider access for those triaxle dollies on the same network as the tandem axle dolly A-double combinations, but there would obviously be some conditions. So some of those conditions would be around onboard mass, and it would also be that the axle mass for the dolly group would be capped at what we're aiming for is not just tandem dolly axle masses, because you've got to take into account that your payload is impacted by the mass of the additional axle. But we'd be looking at similar kind of payload elements of for a tandem axle dolly combination. So that's something that we are researching at the moment with our engineers to see, is that possible, just so that those vehicles that are prevalent in other jurisdictions and within New South Wales can start getting far greater access, at least in a comparative payload form as a tandem axle dolly.
Thanks, Scott. Okay, you've got time for... Les wants to say something.
Sorry, Scott. And just an example in terms of these reference vehicles and how difficult that is. Generally, the bridge engineers, or when they are assessing structures, they are using reference vehicles which were created back in '94. So in terms of the axle configurations, in terms of the axle spacings or axle spreads within those axle groups, they were basically developed 30-something years ago. So that's the difficulty, that with the new system, if that new system is developed, so you can assess the impacts of individual vehicles on structures, that's going to free up all those opportunities to design different vehicles.
Yeah, hi Scott, Andrew Hall. Just carrying back on from that and understanding the restrictions that we have around triaxle dollies, particularly in A doubles, but across the PBS system as a whole, is there a reason, because following on from what Paul said earlier, 90-day extension demands from Transport for New South Wales are becoming more of the rule than the exception these days with permit applications. And we're being told that predominantly they're around bridge assessments. Is there a way that we can fast track identical permits for identical routes for identical units that have obviously been approved before? I know locally there's quite a lot. Access into Bathurst is one in particular where there's a heap of triaxle permits that have been granted. Obviously assessments have been done. So is there a way we can fast track that in any way, maybe through your stand-up of your restructure or whatever, to get those like-for-like permits approved for multiple operators?
Yeah, great question. And certainly there's a fair bit of opportunity for us to do things better. So we're working with the NHVR to get a better understanding of often the cases come out as then the individual cases. So for New South Wales, I think as the state road manager, I think we're going to go close to nearly 40,000 applications this year. It's a lot of permit applications to be processing, and of course, none of those have just one bridge and one road attached to them. But they'll all come out, and we need to then try and find how there is similarity between them. So every time you open one, you then are presented with axle spacings and vehicle specifics, etc. So being able to track and compare where has this vehicle, whether it's owned by the same person or not, is really irrelevant. We treat each of the vehicles as just a set of axle spacings, axle masses, contact width, etc., like performance elements of the vehicle itself. We don't care what colour it is or whose sign is on the side. So being able to have a clear view of where that exact matching vehicle has already been assessed against that matching bridge, that's something that's a very manual process at the moment. So as I said, we're working with the regulator to get better at how we can extract that information. We're also even being able to identify what the new reference vehicle should be, because to Les's point, we've gone based on the reference vehicles that we know of, but being able to compare all of those vehicles and see, well, what is the new trend in reference vehicle for axle spacings, et cetera, to be able to look at those vehicles in a network sense. So then all of those vehicles start to move off permits altogether. The other element is the extensions are very much, that volume around assessment volume does has an impact, and we are working in this restructure process to try and amend that or be better prepared and equipped for that. We're also, through that automated access system, we are moving to a world where this is a thing of the past, and everybody can reach in their pocket and pull out their mobile phone. It wasn't that long ago that all of the stuff it does, we would have only dreamed about, and I'm pretty sure there'd be nobody in the room that can't remember a time when there wasn't a mobile phone, maybe ethics accepted. But the challenges are coming, like the opportunities are coming thick and fast. And the last one is, and once again, still working with the regulator and more broadly, so this isn't just an easy fix, this one, but the rail infrastructure managers are people that we heavily rely on, and that connection is something that is, it's not front of mind for them. It's not their core business. It's a workload that they haven't really understood or had visibility of previously. And as we make better decisions, more deliberate risk-based decisions, we obviously need to include people that have those assets and have risk in that decision-making process. And that means that you're taking people from local road managers, and state road managers have been doing this for a little while. State road managers, obviously, for the longest period, and then local road managers come in a more deliberate way since the HVNL. But the rail infrastructure managers, while they've had exposure to it the whole time, their degree of sophistication and focus on it, in fairness to them, has not been anywhere near the level that it needs to be. And I think they're becoming more aware of what that challenge is. We're fully aware of what that challenge is, and we're all trying to support each other to make sure that that outcome is as good as possible. And as I said, the regulator is also helping us in being able to get them into the portal so that they can operate in as maximum efficiency in this interim period as well, similar to how road managers interact with that decision-making process. So you get a better visibility of where it's sitting and what the challenge might be for delay. And obviously, as I said, rail infrastructure managers get access to the full amount of detail as soon as possible to be able to do that decision-making process as efficiently as possible.
Awesome. Thanks, Scott. I'm going to pull us to a close for session one, which was around high productivity vehicles. So thank you, Les. Thank you, Scott, online.